Proposition 3, Book 3. Having a circle and a line passing through the center of the circle, a straight line, and bisects another straight line that is not passing through the center, it must be necessary the case that it also falls in a perpendicular form. This proposition has two parts. So this is the first part, and then I'm going to demonstrate the other part. So now we need to demonstrate that it falls in a perpendicular way. So we have our circle, our center, and we pass through that center, crosses or passes through that center a straight line, and cuts another straight line. Or actually it bisects this other straight line, and so this is going to be equal to that. Now what we're going to do first is to connect this point to this point and this point to this point over here. We know we can do that, we know that's possible, so we're just going to do it. So we connect them. And what do we know now? What do we have here? We know that this is equal to this, right? We also know that this is equal to this. And this third line is equal to itself. So if we have these two triangles over here, these two triangles, we know that this is equal to this side, and this side is equal to this side, and this side is equal to itself. So we have the side. What does it mean? That the two triangles are equal to each other, and the angles opposite to the equal sides are equal to each other. So we will have that this angle is equal to this angle over here. This angle is equal to this angle over here. And this angle is equal to this angle over here. Whoa. What do we have here? We have that this angle is equal to this angle. What? And we have that this has a straight line, and this is another straight line falling upon this straight line, and we know that it will generate two adjacent angles equal to two right angles. But we know that this is equal to this is equal to this, and we know also that they are equal to two right angles. Therefore, it must be the case that these two angles are right angles. Thus, we have shown now here that if we have a circle and a straight line falling upon, crossing through the center and bisects another straight line that's not crossing through the center, it will be the case that it also falls perpendicular. So, quod erat demonstronum. This is the first part, and now we're going to go to the second part. So we are just going to... Now, it's another case. So, what do we have here? We have again our circle. So the second part is like this. Having a circle that a straight line is crossing through the center, and it's falling perpendicular to another straight line that is not crossing through the center. That straight line must be bisected. That's the second part. We're going to do that. So we have the same thing here, a line crossing through the center, and by making falling perpendicular to the two perpendicular to the straight line. So these two will be right angle and right angle. What we're going to do is we're going to the same thing as the other one. we're just going to connect this point with this point and this point with that point. Simple. So you're just going to do it because we know that we can do it. We have the power to do it and the authority to do it. So we do, just do it. We do it here and then we do it here. Done. That's simple. Let's see now, we have two triangles again here, two triangles. And another thing that we have is this a right angle and this another right angle. Now let's see what we can conclude about this. We also know that because these and these are radii, so they're equal to each other. We know that. We also know that if we see this whole big triangle over here, this is equal to that, therefore there is an isosceles triangle, this whole triangle over here, therefore the angles at the base are going to be equal to each other. So this angle over here is going to be equal to this other angle over here. They're equal. Great. So what do we have next? Oh, wait a second. What do we have here? We see that this is equal to this and this is equal to this. And we also know that this angle is equal to itself. This side is equal to itself. So wait, I think I remember something. That's true. I don't know if you remember, but I do. If we have two triangles in which they have two angles equal to two angles and the side equal to the side, they're going to be, the triangles are going to be equal. What do we have here? Two angles equal to two angles and the third side equal to side. So we have angle, side. Whoa! Therefore, these two triangles are equal to each other. And the same thing, the sides, the angles, the remaining angles are going to be equal to each other. And as we know also, the sides opposite to equal angles are equal to each other. Therefore, what do we have here? We have that this is going to be equal to this. And we have already that this is equal to this, so this is going to be equal to that. Oh, what does it mean if this is equal to this? Oh, that's true. If this is equal to this, it means that this straight line has bisected this other straight line. Whoa! Thus, we have shown now that in a circle, if we have a straight line crossing through the center, it will, we have two cases. Actually, it will, and it crosses through the center and falls perpendicular to another straight line that is not crossing through the center. It will bisect that other straight line. Quod erat demonstronum. That's all. We had the two cases. The first one, if a straight line crossing through the center and it bisects another straight line that's not crossing through the center, it will be also falling perpendicular. And this case that we have shown now, it says that that having a circle and a straight line crossing through the center and falls perpendicular to another straight line that is not crossing through the center, it will generate. It will bisect this other straight line. That's all for today, and thank you. See you soon.